Good morning, students. Okay, the next topic is source shifting. But here, current source and voltage source, always two sources. If the network there is no impedance series with voltage source, there is no impedance in parallel with current source, then source of cannot be directly applied. In such cases, source shifting plays an important role due to the shifting of source, series or the shunt impedance as per the requirement can be achieved, which is some transformation can be applied to simplify network further. Okay, here the impedance will be Z1 and Z2 with the voltage source V1. There is no single series impedance with the source V1. It cannot be transferred to the current source. Okay, so not single source. Here the two impedance will be shifted with the voltage source with series V1 and Z1 and V2 and V1 and Z2. Here two impedance will be source will be shifted. V1 is with respect to Z1, V1 is respect to Z2. It means that V1 is both the impedance will be connected. The voltage source V1 can be shifted through the node C, get the new identical voltage source Z1 and Z2 independently. That is independently Z1 and Z2, Z1 V1, Z2 V2. Okay, next Z1, Z2, Z3 with the source V1. The V1 connects the three branches shown. Here such cases V1 cannot be shifted through the node B, the new identical voltage source. Then current source shifting. Here also Z1 and Z2 with A and B, node C. Okay. If there is a network, there is no single impedance in parallel with the current source. Then shifting to the current source is required. There are no independent, no single impedance in parallel with the current source. Z1 and Z2 is connected, A and B node and C node is connected. Neither two impedance directly in parallel with the current source I amperes. In such case, additional identical current source. Here, Z1 is the current through the I, Z2 also current through the I, this is current source. Z1 is I, Z2 also I, it's a parallel source. It KCL equations at that node due to such shifting now there is existence separate impedance parallel with the current source. Separate impedance with the parallel with the current source. It is a parallel. Z1 parallel with I, Z2 parallel with I. It's a current source. In such current source shifting, there is no change in the currents at the node through which source is shifted. Such shifting is applicable to any number of impedance connected to similar current source. Here also same Z1, Z2, Z3, Z4. All impedance series connected, the part of network. Though impedance Z1 is directly parallel with the current source, so simplification purpose above technique is current. Okay, problems on source transformation, source shifting. Here simple problem network. Okay, 3 ohm, 5 ohm, 4 ohm with one current source 2 amps and 5 volts. Here the 2 ohm, 4 ohm, 5 ohm and 3 ohm. It's also exam problem. Sometimes asked in the examination also, August 2011, 6 marks. Okay, for shifting the 5 volt source in series with the 4 and 3 ohm. 5 volt source series with 4 and 3 ohm. 4 and 3 ohm. This 4 and 3 ohm. 5 volts source. 4 and 3 ohm series. Remaining as it is, 2 ampere as it is, 5 ohm amps, 2 amps as it is. Only this voltage source will be shifted, both the resistance value 3 ohm and 4 ohm. The next diagram, 5 volts, 3 ohm one side, 2 amps as it is, remaining 5, 2, 4, 5 as it is. It means 4 and 5 one side, 3 and 5 one side, 3 ohm, 5 one side, left side, right side, 4 ohm and 5 ohm, remaining as it is. The node C, D are directly connected, hence all the potential, equal potential. So 3 ohm and 5 volts branch can be shown represented, this diagram. It means C and D is a common point, is a one side 3 ohm and 5 volts, another side 4 and 5 volts, remaining 2 ampere current source with the 2 resistance 2 and 5 as it is. Both the voltage sources current converted to current source. Here both the voltage sources 3 and 5. Here also 4 and 5 volts. This converted to current source. How to convert? 5 by 3. This V by R. Here 5 by 4. Remaining as it is. 3 ohm series connected because this 3 ohm, this 4 ohm, this connected series. parallel, because the currents are parallel. 5 by 3, 5 by 4, with the remaining 4 is connect parallel, 3 is connect parallel, remaining as it is, this portion as it is. 5 by 3 plus 2, why plus 2? These current, this 2 ampere current, 3.66, 1.66 plus 2, that is 3.66, remaining 5, 2, 3, 4, here also 4 by 5 by 4 amps. Adding the current source, this 5.3 plus 2, that is 3.6. Okay, next 3 and 5, 3 and 5, this current source to voltage source, next 3.66, this current source to voltage source. Next diagram, 3.66 into 3, that is I into R, V equal to I into R, 3.6 into 3, the 11. Remaining 3 and 5 is series, this 3 and 5 is series, 8 ohm. Remaining 2 ohm, 4 ohm as it is, 5 by 4 amps as it is. Next 11 by 8, 11 by 8. How 11 by 8? V by R. This 11 by 8. V by R. V by R. Remaining 8 ohm, 2 ohm, 4 ohm, 5 by 4. Next, combining the current source 11 by 8 and 5 by 4. 2.6. Remaining 8 and 4 will be parallel. 8 and 4 will be parallel. That answer 2.667. That is, currents reduces as shown in the figure using current division, that is 2.625 current into 2.667 ohm divided by 2.66 plus 2. The answer is 1.5. What is the V? I into R. I into 2. What is I? 1.5 into 2. Okay, next problem. The next diagram, reduce the network shown in the figure. A single voltage source series with resistance using source shifting. 2, 5, 45, 8, 35, 6. This is one problem. January 2006, 13, July 2006, 6 marks. Sometimes asking the examination. It's also important problem. The shifting current source 45 amps through the node. 45 amps. This 45 amps is shifting both the ohms, 2 ohms and 5 ohms. First step. Remaining as it is, 33, 6, 8 ohm. Current source. Current source. Next, 45 into 2. Current source voltage. 45 into 2, 90. 45 into 5, 225. This is 225, this is 90. 2 ohm series because this 2 ohm. 5 ohm, this 5 ohm. Remaining as it is, 8 ohm, 30 volts, 3 and 6. Next, 90, 2 and 8, 10 ohm. This series, 2 and 8 series, 10 ohm. 90 as it is. Next, 5 and 10, 15, 225 as it is. Okay, remain this portion as it is, 30, 3 and 6. Next, shift the voltage source 30 volts through the node C. This voltage source shifting both the sides, 30 volts and 30 volts, meaning 3 and 6. It's same, 90, 10, 225, 15. Previous. 90 minus 30, this source. 60, 90 minus 30, 60. 10 as it is, 225, 15 as it is. 60 by 10. Because of voltage source to current source, V by R. 225, 15. Next 30, 3 ohm, 6 ohm. 60 volt, 225 volts, the equivalent to current source. Next, current source. 60 by 6, next 225, 15, 15 amps. Remaining as it is, 10, 15, 6, 30 as it is. Okay, next 15 minus 6, 9 amps. 15 minus 6, this upward, this downward, 15. Down, 15 minus 6, 9. 6 ohm as it is. 6 ohm, both sides, 10 amps. 5, 10, 30, 30 by 3, V by R, 10 amps, 3. 6 and 3 parallel. Next, 10 and 15 parallel, that is 6 ohm. This 6 and 3. Okay, 10 and 15 is 9 amperes, 6 ohm, 10 ampere, 6 and 3 parallel, 2 ohm. Next, 54, 9 into 6, current source voltage 54. Next, 10 and 2, 20, 2 ohm as it is, 6 ohm as it is. 15 minus 20, 34, 6 plus 2, 8. Okay, stop the video. Remaining next class. Thank you.